So we use the bilinear transform to go from the Laplace domain to the Z domain, and we have this substitution that S is replaced by 2 divided by capital T, where T is the sampling period, times Z minus 1 divided by Z plus 1. So if we do this substitution from here, we replace S by this here, we have this equation here, which is the transfer function now in Z, and from this transfer function we can have y of z and x of z. So this is the definition of the transfer function, the output divided by the input, and then we just cross multiply here, we will have here. And now if we take the inverse z transform, we can get our difference equations. But before, let's just do using SimPy to go from here to here. So what we have now, I'm defining here the bilinear transform here. So is this definition here. And now I'm just replacing S by the bilinear transform. And we have this, just is the same as here, but just so we can see it a bit more clear, I'm using this simplification in SimPy and collecting. So we end up with this. So we have here 2a t omega, 2a t omega. Here we are using the negative powers for z, so z to the power minus 1, z to the power minus 2. Unfortunately, SimPy cannot work with negative coefficients for the exponentials, but if we just divide everything here by z to the power of 2, we would get the same result here. And we can see we have also this term 4 plus omega t squared. We also have this 4 plus omega t squared without any z, which is this 4, this here, and we have all these other parts. So what we're doing now is we're taking this inverse z transform from here, and we'll get the following difference equations. So we have an equation, this is the input, it depends on the past values of the input, and we have the output, and it's also depend on the past values of the output.